Now what we're going to do is we're going to, once again, here you go. This is where we're dealing with concentrations. And yesterday we discussed the concentration of a solution is the measure of the amount of solute in a given amount of solvent. Okay, this is already in your notes because you guys did this yesterday. Okay, so we're going to go through this fairly quickly. We talked about dilute solutions. We talked about concentrated solutions. And we said, could something be concentrated and dilute? Could something be concentrated and dilute? It's depending what we're comparing it to. Okay, it's depending on what we're comparing it to. So those are more comparisons than anything. What we like is values. So we talked about molarity, we talked about molality. Molarity is the one we're going to work some more examples on today. Moles of a solute in 1 liter of a solution. Molality was moles of a solute, kilogram of solvent. So we said that the molarity, symbolized with a capital M, is moles of solute over liters of solution. Now, here we go with our first example. So go ahead and copy down the example and then we'll work it. My question states, what is the molarity of a silver nitrate solution that has a volume of 100 milliliters and contains 29.66 grams of silver nitrate? Well, I know with my molarity, I need moles per liter. I can get liters easy enough by simply taking and jumping my decimal point. So my liters is going to be 0.1000 liters. Now I need to get moles. Well, if I've got grams, I can do a nice little flux capacitor conversion if I have the molar mass. Now, I've already calculated the molar mass, so I'm going to take 29.66 grams of silver nitrate, and I'm going to flux capacitor that into moles. Well, I know that 1 mole of AgNO3 has 169.8731 grams of AgNO3. So, when I do my math, I am going to come up with a value of 0.1746, and my label is going to be moles of silver nitrate. So now that I have my moles, okay, this is nothing, that's just a little flux capacitor guy. Now that I have my moles, I know that my molarity is equal to number of moles divided by the number of liters. So I'm going to take the 0.1746 divided by 0.1, and I'm going to get how many sig figs? I got 4 sig figs here. So I'm going to get 1.746 molar AgNO3. In the blue there is my answer. This is very similar to the example we worked yesterday. Now, my next example. Copy it down, I'll get. Now this example is kind of working backwards from what I just did. Okay, kind of working backwards from what I just did. I know that molarity is the moles, I'm just going to abbreviate it, moles of the solute divided by liters of solution. I'm just going to plug these in. So I know that I have a molarity here of 3.5. I know that I have 1.50 liters. So in order to solve for moles, I'm going to multiply both sides by 1.50. .5 times 3.5, my moles are going to be 5.25. Now that is moles of magnesium chloride, correct? I don't want moles of magnesium chloride. I want grams. So now I've got to flux capacitor that moles into grams. So I'm going to take 5.25 mole of magnesium chloride. Set up my conversion box. My magnesium chloride's molar mass, 95.211. My moles of magnesium cancel. I'm going to get my final value in grams of magnesium. And with 2 significant figures, well, this is going to be a good one. My value I get is 499.85775. How do I get that into 2 significant figures? Okay. It's going to be 500, but 500 is only 1 sig fig. I'm going to put a bar over right there. I'm going to put a bar over right there, and I'm going to label that grams MgCl2. The bar says that that number is significant. Now, you can't put a bar on WebAssign. So if I'm doing WebAssign, I put this into scientific notation, which would be 5.0 times 10 to the second. Move my decimal point 1, 2, and put it into scientific notation. Now, our final example is our hardest one. Go ahead and copy that, and then we'll talk about it. My question states, what volume in milliliters of a 0.500 molar solution of copper 2 sulfate is needed to react with excess aluminum to provide 11.0 grams of copper? This has got a lot into it, folks, because my final product of copper is not what they're asking me for is what I started with, and they're giving me a value for my final product of copper. All right? Well, what I need to do is I need to remember that molarity is moles over liters, right? I am trying to find what? Liters, because I need to convert that to milliliters. Do I have molarity? Yes, I have 0.500 molar. So somehow I have to find moles, but it's moles of what? Copper 2 sulfate. Now, can I find moles of copper 2 sulfate with what I'm given? Absolutely. I'm given this, right? I'm given that. Haven't we discussed going from mass to moles in stoichiometry? What do we need to have to do stoichiometry? A balanced chemical equation. So, what am I reacting? What am I reacting? Aluminum plus copper 2 sulfate. What kind of a reaction am I dealing with here, folks? A single replacement. Will aluminum replace copper? What do I need to check? My activity series, okay? We did a lab similar to this. Matter of fact, my other class did it yesterday, where you had to put it and let it dry in the oven. Okay, so you did something similar to this. I know that aluminum will replace copper, so I'm going to get aluminum sulfate and copper. Now all I need to do is, let me finish this guy, I guess. All I need to do is balance. So I'm going to put a 3 here, I'm going to put a 2 here, and then I'm going to put a 3 here. So now what I need to do is I need to go from 11.0 grams of copper, and I need to take that into moles of copper 2 sulfate. So I'm going to use some stoichiometry here. Thank goodness I remember stoichiometry. I'm going to do a flux capacitor move to get copper into moles. Well, I know that copper has a molar mass of 63.546 grams of copper is 1 mole of copper. My grams of copper cancel. I have now converted that into moles of copper. Did I want moles of copper? No, I wanted moles of copper 2 sulfate. So now I've got to do a molar ratio move. So I look up and I say, okay, in my balanced equation, 3 moles of copper are 3 moles of copper 2 sulfate. Now I've converted that into moles of copper 2 sulfate. Isn't that what I needed for my equation right here? Yes. So when I do the math, I'm going to get my moles of copper 2 sulfate to be 0.1731 mole of CuSO4. We okay thus far? We're good yet right now? Okay, now what I'm going to do, I'm just going to give myself a little bit more room. Let me extend that page a little bit. I'm looking at this right here. If I manipulate my equation, excuse me, once again, I know that liters is equal to the moles over the molarity, correct? Everybody understands the algebra in that, how I did that, right? Okay, what are my moles? 0.1731. What's my molarity? 0.500 molar. So when I do my math and divide that by 0.500, I get 0.346 liters. Did my question want me to solve for liters? No, it wanted what? Milliliters. So how many milliliters is 0.346? So I need 346 milliliters of the 0.500 molar copper 2 sulfate solution. When I mix that in and I throw in 11 grams, or excuse me, I throw in excess aluminum, it'll give me 11 grams of copper. Should I put copper 2 sulfate? Probably. Okay. Any other questions? Okay.